Hi everyone, welcome to Lab 3 Circuits. So the purpose was to predict the behavior of circuits with resistors in series and in parallel, to use multimeters to measure values of conventional current and potential differences, and to explore resistors and capacitors. So the only materials that I used were an online circuit construction kit and Excel. And for the results, the node and loop rule hold true, and current in an RC circuit is time dependent. The system was the circuit, and the surroundings are everything else. So now for the fundamental physics ideas. So the first is the node rule, and it says that current flowing into a node must equal current flowing out of it. So current in equals current out. And then the loop rule says that the sum of all electric potential is zero because of energy conservation. And then the third is Ohm's law, which states that current through a conductor between 2 points is directly proportional to the voltage across the points, or delta V equals IR. So for the first part of the lab was charge conservation and energy conservation in series circuits. So first I predicted the readings on the ammeters by using Ohm's law and using the combined voltage of the batteries and the combined resistance from the two resistors. And I showed my calculations below for that. So that was my predicted current for I2 and I3, or I1 and I2. And then the ammeter readings showed 0.2 amps for both as well. When one of the ammeters was flipped, it made no difference in the current reading. When the voltmeter was added, it read 3 volts because there's no other voltage drop in the circuit. The ammeter changed to 0 amps because the voltmeter had a very high resistance. The following is the voltage drop at different intervals, and the sum of the potential differences is 0, which supports the loop rule. The image on the right shows the completed graph of potential versus position around the circuit. Batteries contributed to a gain in potential, while resistors created a potential drop. The ammeter reading didn't change when you attach the voltmeter because the voltmeter has very high resistance, so little current flows through it. When attached to the 100 ohm resistor, the voltmeter read negative 2.04 volts. When the ammeter was added in parallel with the 100 ohm resistor, the ammeter read 0.06 amps. This is because the ammeter has a very low resistance, so the current will go through it instead of the resistor. The calculations to the right show how Ohm's law was used to calculate the resistance of each circuit element. So I have the resistor, the 47 ohm resistor, the 100 ohm resistor, the wire, and then the ammeter as well. Okay, now for the second part, which is RC circuits. So the image on the left shows charging the capacitor. Charging took about 10 seconds for a 100 ohm bulb and 20 seconds for the 20 ohm bulb. And then discharging took about 10 seconds for the 10 ohm bulb and 20 seconds for the 20 ohm bulb. And I made little switches so that I could change the circuit where needed. Okay, now to answer the question, what is the RC value when the 9-volt battery, the capacitor, and the bulb are connected in series? So this is the graph of the experimental relationship between the natural log of the current voltage over initial voltage versus time. I found the predicted time constant by multiplying the resistor and capacitor values. I then found the experimental time constant by dividing 1 over the absolute value of the slope of the line. And both of those values were pretty similar. All right, now for sources of error. So the first was when waiting for the capacitor to charge and discharge, it was very difficult to stop and start the stopwatch on time. And the second one is online simulations are just simulations and don't always replicate a real-world situation. And now for the discussion. So what if I used an actual ammeter? So the actual ammeter would have resistance and actually limit the total current in the circuit. And what if I had used an actual battery and no resistor? With no resistor, the model would predict that the capacitor would charge instantly, but in reality, batteries have internal resistance. And that's it. Thanks for watching.